This is the energy and momentum quiz number 4. So our question asks, if it'll focus, 2 kilogram spaceship is launched straight upwards from 0 speed. The force of thrust is constant 37.7 newtons until the rocket reaches a height of 21.5 meters and the thrust ends. Neglecting air resistance, determine A, the speed of the rocket when the thrust ends, and then one decimal place, make sure it's positive. So we start out by identifying all of our initial conditions. We write down that the mass of the spaceship is 2 kilograms. The velocity at position 1, which I called V0, is 0 meters per second. The force of thrust is 37.7, which is constant and doesn't change. And then at height 21.5 meters, the force of thrust is 0. And we'll write down what we need to find. The final velocity at force thrust equals 0, so at the height of 21.5 meters, and then we need to use the energy momentum methods. So went ahead and drew a little diagram at position 1. We've got V0 equals 0 meters per second. The mass of the spaceship is 2 kilograms, which is constant through all of the positions. The force of thrust is 37.7, which is constant through the first two. Which I guess technically there's only 2 positions, but I decided to draw the second one just for continuity. So we're not sure what the velocity is throughout, but we know that the acceleration is constant. The mass stays the same, force thrust stays the same, and then at position 3, this is where we need to find the V0, and the mass of the spaceship is 2 kilograms. Same constant. Force of thrust is 0, and the acceleration of the spaceship is 0 at this last position. So then once we do that, we write out our energy momentum equation. So we have our kinetic energy at position 1 plus our potential energy at position 1 plus the work to get from 1 to 2 equals the kinetic energy at position 2 plus the potential energy at position 2. So I went and inputted all of our variables. So kinetic energy is 1 over 2 mv squared. Our potential energy is mgh, which, by the way, the kinetic energy, that is 1 over 2 mass times velocity squared, and then the potential energy is mass times the force of gravity, which sometimes is acceleration, but in our case it's gravity, times the height, and then plus the work, which is the force times the distance, and then same thing for position 2. Kinetic energy is 1 over 2 mv squared plus mgh, except in this case this is the velocity at position 2, and this one is the height at position 2. So we're able to cancel out the first 2 because velocity is 0 at position 1 and height is 0 at position 1 also, but the work is going to stay there. And then these 2, we will have mass, we will have velocity, we will have mass, gravity, and height here. So we can leave those. So we'll input all of our numbers that we had from up above, our 37.7 newtons of thrust, our 21.5 meters of height. Is it meters? Yeah, meters of height. And then we have our 2 kilogram weight. We have our unknown V for our final velocity. Our 2 kilograms, negative 9.8 meters per second squared, and for the height, 21.5 meters. And the reason why I put this one as negative is because at first I thought it would be positive because we are going from 0 to oh, actually I guess that makes sense because our position 1 is 0 and our position 2 is 21.5, so we actually use 0 minus 21.5, but I intellectually got there because you would obviously have to have since your initial potential energy is 0, your final potential energy would have to be higher because the rocket is higher than when it was over here at position 1, so that number would have to be negative because mass can't be negative, gravity is negative, so that one would have to be negative so we could get a positive number there. and then when we do our calculations, and then once we isolate our velocity equals 19.727 meters per second.